Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
So the moment of truth has eventually arrived. It's time for us to evaluate or to assess our predictors to determine who is the winner and who's the loser, so to speak. So that's going to be the focus of this video tutorial. And most of the work will happen in Excel. But obviously we can do that assessment in RStudio, you can do it in QGIS, but I'm going to focus on Excel. I simply just enjoy working in Excel, but that's a personal preference. So remember, we created this 4,903 random points, which we tested for complete spatial randomness. That was the focus of our previous video tutorial. And then, so we've got this point vector file, point vector layer, with all the predicted values for each of these 4,903 locations. So we've got this file within QGIS, and then I'm simply just exporting it as a CSV file to my project folder. So I've already done that. So it's lying within my project folder. If I go to my project folder, it's there, it sits. There it sits. I open it. I open the file, and it's in the CSV format. Okay. Now there's nothing much you can do in CSV format. So what we now need to do is to convert this from a CSV format into our Excel format. So in my case, this might be dependent on Excel to Excel or computer to computer, but in my case, I simply just highlight column A. I go to data, and within data, I go to text to columns. I go to delimitate it. I go to next, and remember it's a comma. And you see there it automatically delimitates the data into individual columns based on the comma. Okay, so I'm just gonna go further. I'm just gonna press finish, and there it is. Now these values are all in point format. You'll see they all have points. Now again, in my Excel, it doesn't like to work. It sees the point as a what do you call it? It's not as a number, but as a letter. So for example, if I do this, say let's highlight those. I say insert, and I want to make a line graph of it, or any graph. You'll see there's nothing happening because it's taking this value as a not as a value per se, but as a number. So I need to there's my coordinates. So what I need to do, I need to basically go find, and then I need to say find what? The dots, and I'm going to replace it with a comma. And it's going to take a bit of time because there's 4,903 of them. It's 132,380 replacements. Now as you see, if I do this now again, select that, I go insert, I go line graph, there's my line graph. So I had to do this. Now let me first save this. So I'm going to save this in my folder, and I'm going to save this as an Excel file. Not as a CSV file, but as an Excel file. And voila. Now it's saved. Let's just make that a little bit more pretty. I'm going to just do this. Make it all center. Shall we make it okay, so that's the I'll make it 2 decimal points. Let's make it 2 decimal points as well. Format, number, 2 decimal points. There we go. There we go. Now I want to do a little bit of rearranging because I want my variables, the 4 variables specified in the beginning of my spreadsheet. So now I need to find, there we go, that's the one. So let's cut this one and we're gonna paste it in there. So we can delete this. We need to actually rearrange them a little bit better, but anyway, let's just, so we're gonna do rain and temperature. We're gonna cut these two. Okay, so they want cut. So we're gonna go rain, and we're gonna do temperature, and then elevation. Then elevation, where will there's elevation cut. And now we can delete these open columns. So now we've got them. So that's our actual value, and here starts all our predictors, our predicted values. There should be 23 of them. So the first thing that I want to do is I want to generate a correlation matrix. I want to generate a correlation matrix for each of them, and meaning the actual value and it's the correlation with each of these predicted values, time series. So let's go to the first one, which is 8, H. So we're going to say equals, so we're going to do the first one will be correlation, and obviously we're looking for the one with the highest correlation. So I think it's H. Yep, H. So we can say equals correlation, open the bracket, and then I'm going to select my actual values, which is column D. There's a lot of them, just be patient. I presume I can just write it in as well to save a bit of time, but I'm almost there. Okay, so that's D, and then it is E2, E4904. That's the correlation number. Let's format it also 2. And I'm just going to highlight it. Now I'm going to anchor our actual ndvi values, and then I'm just going to drag to the right. So I anchor D, column D. Why is it? It should be column H. Sorry, column H. Here we go. 0.92. So that's a very high correlation between the actual values and the predicted values for the, which one is this? The Mansky model, which is a spatial econometrics model. So, given that I have anchored the actual, we're just going to drag it down. And that will give us the correlation values for each of these ones. Now, what I want to do is, I want to create a ranking structure. So, let's quickly take, so the first thing that I'm going to do, I'm going to convert this data, I'm going to transpose my data. So let's highlight all the variables, the predictors. I'm going to right click and transpose. I'm going to transpose them. And what are we going to do now is we're going to have the correlation, and we're going to transpose it as well by using the matrix notation. Come on, why did it do this now? Correlation, sorry. So let's make it. So I'm going to select this, and then we're going to, come on, not that one. We're going to say equals, and we're going to say transpose, and then I'm going to select the correlation matrices. I'm going to close it and then Control Shift and Enter, and voila. And then we're just going to make it another two decimals. Make sure 1, 2, 3. Let's just count them. 1, 2. There should be 23 of them. 22. Ooh, which one are we missing? I'm missing I'm missing A. Which one am I missing? There's definitely one that we are missing. Ooh. 0.91. Ooh, which one are we missing? We're missing one. Well, we'll figure it out now. We have the SVM curve. SVM curve. So it's there. Anyway, so let's rank them. So we're going to say equals. In fact, what we should have done. Okay, let's do this. Nope. So let's just do this insert here. We bring this correlation down, and we can just say here type. So what we can do is we can use our sorting method. Sort from largest. Okay, so he doesn't want to do that. So largest, nope, doesn't want to do that. No problem. So what we're going to say is we're going to rank. So let's say correlation rank, and we're going to say equals, and we're going to say rank. The number, and then highlight all the values, and we're going to say the order and descending, lists and descending, rank sorting, that's one. So let's anchor our range. So we're going to anchor our range, and let's rank them. So the Mansky top performing, followed by WR, which is a weighted regression. There's another weighted regression, is number 3, and the final geographically. So the 3 geographically weighted predictors or models seems fairly accurate. And this is a spatial one. Let's have a look. There's a random forest in R. Random forest in Earth Engine. Which is the worst? 22. Which is 22? Where's 2022? It's 21. Is the LMS, it's the time series one. You'll see the time series one seems to be, there's 22, which is the, I think the DM. Oh, that's a spatial DM one. Actually should order them, indicate which ones. Anyway, so that is one method. That's one method. The other method is to generate the root mean square error. So let's quickly do that. Now we have to do a couple of other things. So remember, first of all, we need to generate the square error. Okay, we're going to generate the square error. So we're going to say equals power, and it will be the power 2, we'll square it, but we'll power of the error, which is the actual values minus the predicted values. So it's the actual values minus the predicted values squared. So that's the first part, and I'm just gonna, so that's the mean, the root mean square, that's the mean square error. Oh, that's a square errors part. That's a square error part. I'm also gonna anchor the actual ndvi. Oops, so not the anchor the apps, because I'm gonna drag it to the right. I'm gonna drag it to the right. Let's just quickly see. Yeah, let's drag it to the right. Oops, sorry. I'm going to drag it to the right till it's still more. Can still drag it further. Come on. Can still drag it, I think. 3 places. Let's make 4 places. There we go. Up to here. From this point onwards, there's nothing. Okay, so we've calculated now that. So what we now need to do is we need to, because the reason why we do why we take the power is to get rid of the minuses. So that's why we use the power function. Next one, what we're going to do is we can now either calculate, we're going to sum all of these and get the square root. So we're going to say equals, and we're going to say again power, power. We're going to take equals power. And we're going to take the power, the power is now going to be 0,5, which is the square root. And we're going to sum all these values. We're going to sum all these values, and we're going to get that. Why is it giving 0.5? Nope. Why is it doing this now? 0,5. Giving me that. So let's quickly go equals square root number is equal to is the sum of all these values. And there we go. So that is the mean square error. We did mean square error. And let's go to the right. That's the mean square error. Root mean square error. And we're going to also just transpose it. Equals transpose. And we're going to also 2 decimals. I can't see that. 2 decimals. Then we can just rank it. Just copying and pasting. I'll do the. We're going to do the rank. Yep, it's already done. Okay, so let's quickly see. Whoa. So here we wanted actually the lowest value. Here it was the highest value. So what we have to do here is when we go into the rank, we need to put a 0 there. Is a number 0 or 1? Okay. So we're going to convert it into 1. There we go. So the order seems very, very similar. The first is still the Mansky one. Lowest root mean square error. lowest root mean square error, the lag error one, the lag y one. It looks very similar. We can obviously do a comparison. The last one that I'm going to do is the mean absolute deviation. So that's the last one we're going to do. So we're going to do pretty much the same as we did root mean square error. So we're going to go absolute, and we're going to subtract the actual minus the predicted, and it's going to give us an absolute value. Again, we want to get rid of the minus, so let's just quickly make we anchor the actual values. We anchor that, and we're going to go down. It's always an issue where to stop. For the sake of accuracy, let's copy these ones, copy it, and you're going to paste it in here. I'm just going to give it a background color to make sure that I know where it stops and where it starts. And we're going to give this another background color, which is, let's say, that color. And there, I should have gone that one. Okay, so I've got all my values correctly, and I'm just going to double click on it. It will automatically fill down, and then I'm just going to get the mean of that values, which is equal to, here we go, mean or median. We can play around with this. Let's go mean for keeping true to the name of the method. That's going to be that one. Let's just make sure. Yep. Average. Take it down. Okay. This case, let's again transpose it. Equals transpose. Where's my transpose? And my values. Close the brackets, Control Shift Enter, and let's redo it. Whatever reason, let's just come on. I'm going to format this cells just quickly correct. Then I'm going to say equals transpose and select my numbers, my variables. Control Shift. And it's done. This one maybe I have to format and maybe make it 3 decimals because they are so close. And let's do the rank. So that was the standard root correlation, root mean square error. And this is the correlation for the, come on, root mean square error rank, and this is the MAD rank, mean absolute deviation. Let's have a look and see if I copy this as is. I'll put it in there, and there we go. Now that's 1 and 2 swap places, but it's marginal. The worst performers, so this gives a little slightly different results as the other two. So let's quickly see if we can put it on a graph. Oops. Let's quickly see that one. That one. I'm just going to plot the ranks because these values are fairly different. I'm going to plot that, insert, and I'm going to use a column chart. And there's the column chart, and I'm basically going just to select the data, include the variables. There we go. So yeah, that's not too bad. So let's just move this to the bottom. I'm missing one. I'm gonna have to go and find out where this missing prediction lies. Does it then just change this? I want this colors. And there we go. From the graph, you can see that the Mansky one, the weighted, geographically weighted regressions, the random forest ones are the top performing. There's another random forest. The worst one is the worst ones are the time series. Why do I only have one? But I've got two there. The support vector models also not performing well, but remember we didn't do the tuning, etc., etc. But this gives quite a nice picture. So what we need to actually do is to categorize these within I think it's 5 categories: random forest, support vector, spatial, geographically weighted, and time series. And we can play around with that to see which categories in general are performing. We just get the average ranks for each of those categories. But that would be also interesting to do that exercise as well. But yeah, this gives us quite a good understanding of the dynamics of my region of interest in terms of modeling or predicting the ndvi values, and what methodology seems to be more appropriate versus other methodologies. But as I said, please just bear in mind that this might be very dependent on my region of interest and with our model itself, or our equation itself, our variables that we've included in our equation, being the time periods that's involved, the number of, all sorts of things. So this rank may or may not be true in all circumstances, but within my circumstance, it certainly seems to be fairly evident that the inclusion of space seems relevant. Versus just focusing on time series. So spatial dynamics seems to be important, and we need to take cognizance of that. Anyway, so that's quite neat, and that's what we wanted to do. Now we can fine-tune all of our models. We can play around with the models itself. We can generate additional predicted images by changing the parameters of the different models, and we can rerun those predictions and do exactly the same exercise for robustness of our results. So that's obviously something that we have to do, but that's maybe something for a later date. I also think that working in RStudio and automating it in RStudio may save a lot of time and effort. Nonetheless, let me say that the results are in, and it does suggest that working with in a spatial context is significant, and the spatial dynamics of ndvi seems irrelevant, and we need to take that into account, meaning the ndvi of a particular location is influenced by the ndvi of neighboring locations. On that structure of the spatial dynamics, the spatial structure, we have to take cognizance in. It's not purely just on the time dimension. So that's quite neat to understand, so that gives a good understanding of the dynamics of the ndvi within my region of interest. So with that, I think that was quite interesting. I thoroughly enjoyed this. This is what which we set out to do when we started, is to generate as many predictors as possible, and then to evaluate those predictors and see what the results suggest, or what the results are implying for my region of interest. Anyway, that's cool. So with that, let me pause there for now. Thank you so much for your support. Thank you so much for subscribing to my channel, and all the messages and comments. I really appreciate it. For those that haven't liked, subscribed, shared, please do so. Smash those buttons, press them left, right, and center. It does help. It is your support is greatly appreciated. So saying that, and yeah, let's onwards and upwards, as they say. Our journey continues. I'll see you on the other side.